This week we are going to be looking at momentum and collisions. So let's first just think about a collision, and we're going to kind of think about what quantities matter when we're talking about a collision. So thinking just for yourself, which object would you rather collide with? Would you rather collide with a tank or with a pair of roller skates? Well, probably most of you are saying you'd rather collide with roller skates. But what if I told you that the roller skates were traveling at 200 miles per hour and the tank was traveling at, 1 inch per hour? I would probably choose the collision with the tank. Okay, so it's not, when you're considering do you want to collide with something or is something going to hurt if it collides with you, it's not just how massive the object is, it depends on also the speed of the object. Next thing to consider, would you be afraid of catching a ball that's going 100 miles an hour with no glove? Most of you would probably say yes, that would really, really hurt, might even break your hand. Well, what if it was a ping pong ball? It might sting, but it's not going to really hurt you. So in this case, this is something that's traveling with a very high speed, but the mass is very small. And so the collision wouldn't be so terrible because the mass is so small. So when we're considering a collision or something hitting you, I hope you can see with these examples that it matters both what is the speed of the object and what is the mass of the object. So we need to introduce a new quantity that's going to combine the speed of an object and the mass of an object in such a way to kind of help us think about what that object is going to do in a collision. And that new quantity is called momentum. So here's our equation that defines momentum. We're going to use the letter P for momentum. And momentum is just equal to the mass of an object times the velocity of an object. So a nice thing to say is momentum is mass in motion. There's the mass, there's the motion. So this mass is measured in kilograms. This velocity is measured in meters per second. The units that we're going to use for momentum are just kilograms meters per second. There's no fancy name for this unit. You think that they would give it a special name, like how newtons is a special unit for force, and that's kilograms meters per second squared. Momentum is a very important quantity in physics, and yet we did not give it its own special units, so we just say kilograms meters per second. Now, momentum is a vector, just like velocity is a vector. So don't let that scare you. Don't let that, make your heart beat faster thinking, oh my God, we have to do all the vector stuff with this. That's true, but I want you to really just think, now we have more experience with vectors. What is a vector? A vector is simply something that has a magnitude. That means how big is it? What's the number? And it has a direction. And in this equation, we can see that whatever direction the velocity of our object is, that momentum is the same direction. So if we have something moving to the right, that object has momentum to the right. If we have something moving, at 135 degrees, something like this, that object has momentum at 135 degrees. That's all that this vector symbol means. If the vector symbol scares you, just don't write it in your notes. Just don't write it, okay? An even better thing would be to recognize that because momentum is a vector like velocity, that we can break our momentum into x and y components. So even better than writing it like this is to write it like this. So the x component of our momentum is equal to m times the x component of our velocity. And the y component of our momentum is equal to the mass times the y component of our velocity. That's just kind of a succinct way of recognizing that this is a vector, but it's not quite as scary looking as writing it this way with the arrows on top. So here are 4 momentum vectors. So just take a second and try to figure out which momentum vectors have a positive x component. Well, the positive x components are the ones the vectors that point in the positive x direction. So A and B have positive x components. How about which momentum vectors have a negative y component? The ones that have a negative y component are pointing downwards, so that would be B and C. Okay. Here's another problem that can help you calculate momentum. In this case, we're going to calculate the change in the momentum of the cart. So here I have a cart that has a mass of 10 kilograms. It's initially traveling to the left with a speed of 2 meters per second. Then it hits a barrier, and after hitting the barrier, it rebounds to the right with a speed of 1 meter per second. And I want you to calculate the change in the momentum of the cart. where here's the momentum before the collision and here's the momentum after the collision, and I want to know how does the momentum change. So press pause and take some time to try to calculate that. Now, something tricky we have to remember about momentum is that it is a vector. So the in this case, positive and negative for our momentum indicates the direction. And so I'm going to, there's the answer. I'm going to be very careful about putting a coordinate system where I'm going to say the positive x direction is to the right. In that case, this initial velocity here is negative, and this final velocity here is positive, and that's very important when we're calculating change in momentum. So I'm going to calculate my change in momentum, that's delta p, and delta p is equal to p final minus p initial, where p final is the momentum I have here after the collision, and p initial is the momentum I have here before the collision. To calculate p final, I would just do my mass times v final, where v final is 1 meter per second. And to calculate p initial, I would do my mass times v initial, and v initial has to be negative 2 meters per second. It has to be negative because it's going to the left. Okay, so I have my mass times v final, which is positive 1, minus my mass times v initial, which is negative 2, the negative because it's going to the left. And so I find that delta p is equal to 30 kilograms meters per second.